a whistle-stop tour through roots of polynomials. So what we are interested in this topic is quadratics, cubics, quartics. You can go higher, but we don't because the equations are really messy. And we're interested in where these polynomials cross the x-axis, i.e. where their roots are. So in this quadratic I've got, which we could call y equals f of x. A general equation for a quadratic, ax squared plus bx plus c. Hopefully you agree with that. And as I said, we're interested in the roots. So that's where f of x crosses the x-axis, i.e. where y is 0. And that's going to give us, at most, on a quadratic, 2 roots. We know there could be 1, we know there could be 0, but we're interested in the maximum number we could have at any point. In order to know where the roots of polynomials equations come from, what I'm going to do is I'm going to use the roots to generate a quadratic equation for this curve. Now, I know it's quadratic in this case. If it were cubic, we'd have 3, and we know we'd be getting a cubic. So I'm trying to generate a new equation for f of x. So one way to do that is to write my roots as their original factors. So that's going kind of one step back, almost backwards through solving a quadratic type of thing. And we know that x minus alpha would be a factor and x minus beta would also be a factor. We have to account for the fact that there could be a stretch on this function, which wouldn't affect the roots, but it would affect every other point on the curve. So we'll add that in as well. Now it's a stretch in the y-axis, so it can sit outside of your factor pairs. I'm then going to expand this out. So I'll leave the a where it is for a second. I've got x squared minus alpha x minus beta x plus alpha beta multiplied through by a, but maybe let's first sort out those x terms. So we could have that as minus alpha plus beta x plus alpha beta. If you're not sure about that, pause the video and quickly expand that to make sure you're happy with what I've done there. And now we can multiply through by a. Okay, so this is an equation for f of x, but I already had one of those. That was up there. So those two things must be equivalent, i.e. ax squared plus bx plus c can be written equivalently as ax squared minus a lots of alpha plus beta x plus a alpha beta. So let's do some comparing, because if that's the case, then this a is equivalent to that a. That makes total sense. That's completely trivial. But this b value on the left-hand side must be equivalent to minus a lots of alpha plus beta. So let's write that down. So b is equivalent to minus a lots of alpha plus beta. And then this c value here must be equivalent to the end term. There's no other alternatives here. So c must be equivalent to a alpha beta. Now, hopefully you can see where the roots of polynomials equations are going to come from. If we rearrange this here, alpha plus beta is minus b over a. And likewise, alpha beta, so the product of your roots, is c over a. And for a quadratic, these are the two equations we are interested in. Now, as we go up to a cubic and a quartic, obviously we generate different terms. So we have an x in a cubic, for instance, an x cubed term, and then an x squared term, then an x term, and then the number terms. And so we actually end up adding in more coefficients originally, and then we have more equations. So hopefully you have seen these before. You can see my quadratic ones here. So I've put sum of alpha, which really means the sum of the single terms. So in this case, for a quadratic, it would be alpha plus beta. For a cubic, it's going to be alpha plus beta plus the third root, which is gamma. And for a quartic, it's going to be alpha plus beta plus gamma plus delta, but the sum of the single terms. And you can see in all cases that's minus b over a. This is the sum of pairs. Now, in a quadratic, that's our final term, that's alpha beta. That's for our quadratic. For our cubic, that's alpha beta plus beta gamma plus gamma alpha, so the sum of the pairs in all its possible options. And for a quartic, alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta, and I always run out, plus gamma delta. Should be 6 there. So it's the sum of the paired terms. Now, for the next column, or rather, sorry, for that sum of paired terms, you can see it's always C over A. For a cubic, so this is, of course, ax cubed plus bx squared plus cx plus d, our final term will be the sum of the triples. So that's just going to be our alpha, beta, gamma. So we only have that for a cubic, that's our final term. For a quartic, though, we have got option. We've got a kind of set of terms here that we can keep moving through, and so on and so forth. In these cases, that's minus d over a. And then finally, of course, for our quartic, we have the sum of all, the product of all of your roots. So that's just your e over a. And of course, the quartic is the only one with 4 roots. So the product of 4 roots can only appear in the quartic, but you can see how that would build up over time. You do need to know these bits, or rather it's helpful. So even if your formula book for your exam might have them in, it's helpful to know them so that you're not having to rely upon that formula book. It does help build your fluency. Okay, so let's have a quick look at the first part of this question, then we're going to flick back and talk about some other bits and pieces, and then we'll come back to part 2 of this. This is from the old specification. It's an OCR FP1 question. You find these questions dotted around all of the exam boards somewhere in their further maths, so do go have a hunt around for them. So we're going to write down the values of alpha plus beta and alpha beta. These are our standard expressions for a quadratic, and it's a write down, so they're not expecting you to do any working really beyond just recognize what you need to write down. So alpha plus beta, the sum of our singles is minus b over a. Now don't forget b and a are the coefficients in the quadratic that you have, and alpha beta is positive c over a. Now for our quadratic, a is k, I'm reading this off of the top here, b is 1, and c is k. That's the quadratic we've been given in the question. So minus b over a is minus 1 over k, and c over a is k over k, which is, of course, 1. So hopefully that makes sense. When we do part 2, we're actually dipping into a slightly different way of thinking about these equations that we've generated. Of course, the equations themselves aren't too bad, hopefully, but what we can do with them gets a little bit more interesting and certainly gets us to play with a load of algebra. So if I focus on a quadratic for a minute, I have these 2 equations that come for free. So alpha plus beta and alpha beta. But I sometimes get asked other stuff, and what I'm going to have to do is force the stuff I've been asked to be written in terms of these freebies. For instance, I could be asked what the sum of the reciprocal roots is. So this is 1 over alpha plus 1 over beta. Well, I don't know what alpha and beta are, so I can't just reciprocate them, and I certainly am not going to go and find them necessarily, not depending on the question. What I'm going to try and do is write this expression, this sum of reciprocals, into a different format so that I can use the freebies that I've been given. One thing to do would be a common denominator, so alpha beta, and that would give us beta plus alpha on the top. So just added those using a common denominator. And hopefully you can see now that we've got our alpha plus beta expression over our alpha beta expression. So we've actually forced this sum of reciprocals to appear in the format that gives us our freebies to use, which is really nice. So we then just substitute in whatever our value for alpha plus beta is and whatever our value for alpha beta is. Another thing they could ask you to do is alpha squared beta squared, which would be the same as alpha beta squared. Now again, all I've done is forced the expression, which is the product of square roots, squared roots, not square roots, squared with a D on the end roots, to appear with my freebie. So I know what alpha beta is, and I can square that, and that's going to give me alpha squared beta squared. We could do something similar with alpha plus beta squared, which is, of course, alpha squared plus 2 alpha beta plus beta squared. And hence, if you were asked for the sum of your roots squared, you've actually got that as a expression in terms of the sum of roots and the product of roots, i.e. your freebies. So, sorry, I've written that one slightly back to front there, but if you were asked for alpha squared plus beta squared, it's the same as alpha plus beta squared, so the whole thing squared rearranged, which is quite nice. So going back to this question then, we know that we've got these roots minus 1 over k and 1 for our, roots, sum of roots, product of roots. In part B, we're asked to find the value of alpha plus its reciprocal root times by beta plus its reciprocal root. Now, we don't know what alpha and beta are, so we're going to have to do our little trick of finding out a rearranged expression, or rewritten expression rather, that's in terms of my freebies. Well, I think the first thing I'm going to do is multiply. So I'm going to have alpha beta, first term, plus alpha over beta, and then beta over alpha plus 1 over alpha beta. So the first and fourth terms there, I think, are fine. I've got alpha beta, that's 1, and so 1 over 1 is also fine. Middle terms, however, are still not okay, but I could add these with a common denominator, so that'd be alpha beta, and that's going to give me alpha squared plus beta squared on the top. Now, the top of that fraction, the numerator, is still a bit of a problem for us, but we have just worked out what alpha squared plus beta squared is as an expression, and it's alpha plus beta squared minus 2 alpha beta. And again now, I've got the numerator of that fraction in terms of my freebies, my sum of roots and my product of roots. So now I should just be able to pop in the values that I've got for each of those terms. So alpha beta, that is 1. And then alpha plus beta is minus 1 over k squared, minus 2 lots of alpha beta, which is 1, over alpha beta, which is 1, plus 1 over alpha beta, which is 1. So we've got 2 plus minus 1 over k all squared minus 2. Those are cancelling, and we're left with 1 over k squared. All we've got left to review on roots of polynomials is linear transformations, which I'll talk about in another video.